Welcome. Welcome to today's science lesson. We shall pick on from where we stopped in the other lesson. We were seeing the natural resources, and we identified under these natural resources, we have renewable resources, and we also have non-renewable resource. An example of a renewable resource, we had seen a resource like water is a renewable resource. We had seen water is a renewable resource. We had seen air is a renewable resource. But now we also have non-renewable resource. And on non-renewable resource, we were starting to consider rocks as a resource. Rocks, we had seen that rocks as a resource, rocks provide two different resources. We had mentioned that one, the rocks themselves as they are a resource. In case you want to use them for building, either road construction, you will use the rocks as they are for construction purposes. So when we use rocks as they are for construction purposes, it is a resource. We also had seen that we can use rocks as a resource, but we are interested in the minerals that are found in these rocks. That is where our point of interest is. And we have seen some of the minerals found in these rocks, like we have some rocks, they contain aluminium, and we know the many uses of aluminium. So we take these rocks, yes, but we extract the minerals, we extract the aluminium from these rocks. When we get this aluminium is used in a number of things. For instance, when it comes to making aircraft, we use aluminium. When it comes to drink cans, we use aluminium, and high voltage power line, we use aluminium. So we know the importance of aluminium as far as development is concerned. Also, when we are interested in rocks, this is what we had mentioned, when we are interested also in rocks, we go to the extent of also looking about the iron. Iron is contained in hematite, and when you go to the iron, we find that iron is made, when you get iron from the rocks, iron is used to make steel, and when we talk of steel, this is used to make car bodies. We make car bodies, nails, ships, and bridges. So we know how important ions are. And then also from rocks, we can get minerals that can be used to make copper. The importance of copper we cannot underestimate. Copper is very important. We know copper is used in electrical wiring. Copper is very important. So we find that now here, the minerals that we extract from these rocks are very important. So when we talk of rocks as a resource, it is a resource itself, but also the minerals contained in them. Then we have rocks like sodium chloride is a mineral that the table salt, we use it for preservation, and also we use it in the preparation of we can also use sodium chloride for medical applications. That is how far we had covered that lesson. Today we are going to see rocks as a non-renewable resource. We are saying that rocks as a non-renewable resource. When we mining companies, when we get these rocks, when we get the minerals that we want, and we use them to make the things that we need, we make iron, we make copper, it is very hard for us again to get the same copper once it is used. Therefore, we are saying, yes, rocks are there, but they are non-renewable resources. We are saying most rocks on Earth were formed many millions of years ago, and we can say that there is a process of forming rocks. For instance, if we talk about the Earth crust, in the middle of when we talk about the Earth, we know in the middle of the Earth we have a place called the core, where the temperatures are very high. And when you go to core, we shall find lava is present in form of molten magma or lava. Now, when it is too hot and due to some friction and so forth, this magma, if it gets its chance to penetrate through the earth crust to the surface or within, if it cools within the earth Earth's surface, then it will cool very slowly, and it will form some types of rocks. But if it happens that this kind of magma or lava penetrates and it overflows and it forms itself on the surface of the earth, then we shall find that rocks such as igneous rocks are formed. Now, when igneous rocks are formed, they are formed because of volcanic activities. So when there is a volcano eruption, volcanic eruptions, when they cool down, they will form these igneous rocks. And from these igneous rocks, we can extract our minerals that we have been talking about. Igneous rocks that are formed below the ground, they take also many millions of years to form, in contrast with the igneous rocks that are formed on the surface of the rock. They cool faster, or those which are formed below the seabed, they cool faster. But those igneous rocks that or those lava or magma that cools beneath the earth, they take millions of years to cool. Other types of rocks that are formed, we talk of sedimentary rocks. How are these sedimentary rocks formed? They are formed from the process called weathering. When there is weathering, rocks will break into small particles, and when they break into small particles, due to the activities of ice, due to the activities of water, and also due to the activities of wind, it can blow up these small particles of rocks, small particles, even the air it can carry. We can have a tornado, we can have wind that can carry small particles and deposit them somewhere else. Where these deposits are made, if it is water, it can carry small particles of these rocks. When they break down due to the process of weathering, they are carried and deposited somewhere by the river. When they continue being deposited in layers, they will form rocks called sedimentary rocks. Sedimentary rocks are formed from rocks that are broken down due to weathering and other activities of ice, and are carried down the river line. Now, when they continue piling, under pressure, they will pile and they will form sedimentary rocks. Sedimentary rocks are not as strong as igneous rocks because these are formed with many particles that are joined together. Most of sedimentary rocks formed thousands of years and many years ago. What happened? And if these sedimentary rocks are formed and they are influenced and they come under tough pressure, they can change their state. Then if they change their state, we shall have rocks we call metamorphic rocks, which are very hard metamorphic rocks. So we have close to 3 types of rocks. We have the igneous rocks, the sedimentary rocks, and the metamorphic rocks, rocks that have changed due to pressure and after very many years, and they are very hard rocks. So we are saying, after talking about these rocks, now we can come to soil. We can come to soil because when we come to soil, we shall be in a position to look soil as a resource. We shall be able to determine whether soil as a resource, is it a renewable resource or not a renewable resource. But what is very important first, we know that there are some, when we talk about sedimentary rocks is not only formed from small particles that are broken down from rocks and so forth. They are also formed from animals, like the fossils. These are alive animals, but when they die, they can also form some kind of rocks. They can form part of the sedimentary rocks. So what happens when these animals die, they form fossils. For many years, they will be able to bring up what we call fossil fuels, which is normally extracted. Now, fossil fuels like oil and coal were formed from dead plants and animals that lived many years ago, millions of years ago, and it is hard to know whether they are still being formed today. Once you mine a fossil fuel, once you mine coal, know that it is getting depleted. We cannot talk of getting more oil. No, oil, fossil fuel is a non-renewable resource. Once it is used, it is gone. So it depends the way we should limit the use of these scarce resources like fossil fuel and so forth. So what we want now to talk about, soil as a resource. Soil as a resource. And you know, soil is a combination of maybe small particles and so forth. There is a way you can improve the fertility of soil and so forth. But let us look soil as a resource. Now, when we are talking about soil as a resource, we are saying that rocks broken down, rocks that have weathered into small particles such as sand, silt, and clay. So whenever we are talking about soil, there are components of soil, and we are saying soil is made up of sand, silt, clay particles. You will find that when rocks weather, when they weather into small particles, they will form sand, silt, and clay. The small particles are carried down by wind, water, and ice in a process called erosion. Erosion. So when rocks are broken down into sand and silt and clay, they don't just remain in the same place. The acts of weather, we can see if they've weathered in a particular way, water can come in. If it rains, water can be able to carry these particles of rocks, these particles of sand, silt, and clay, and through erosion, and they are able to be deposited in a different place. The particles are then dropped somewhere. When these particles are dropped is what we call deposition. When they are placed somewhere, they are dropped somewhere. After these particles are deposited somewhere by either ice, by either water that is flowing, or even by wind, wherever they are deposited is what we call now, where they are dropped is what we call now they are being deposited. We say it is a deposition. And we are saying the deposited sediments, that is sand, silt, and clay, are added to the soil. And where they fall, making making a new soil in that process. So we can say the soil can be able to improve depending on how these particles are deposited. Where they are being deposited, the soil, they are being added where there's another soil. So when silt, clay, and sand are deposited somewhere, then they're trying to form that particular soil. What we are saying, soil is composed of the following. We want to know the components of soil. What is soil composed of? We want to know the components. So we are saying soil is made up of close to 5 components. We can start with component number 1, which is fine rock particles. Fine rocky particles, fine rock particles. So we can say fine rock particles. We can also call them sediments. So these are the components of soil. So we are saying we have fine rock particles. We're not talking about particles that are large. If they are too large, then they will fail to be called particles, and then they will become rocks. So we're saying fine rocky particles. Also, we are saying living organisms. So within soil, we have aeration, meaning within soil, there are some spaces where there is air. So we are saying there are living organisms within soil. Living organisms. These organisms can be in form of bacteria. We have nitrogen-fixing bacteria, nitrobacter bacteria, which can be able to improve the condition of soil so that when it comes to growing of plants, plants can grow well because the soil is well aerated. And it also depends on the plant. If the soil is acidic, it can be fair to a particular kind of plants and unfair to other kind of plants. So we are saying living organisms, and these living organisms can be worms, and the mosses that we know, worms, the worms, and the moss. These are living organisms. These are living organisms that can be found within soil. When you talk of living organisms, we also say soil is made up of humus. Humus is decaying waste and dead organisms. So we can say humus is also another component of soil, and we are saying humus is made up of decaying wastes. Is made up of decaying wastes and dead organisms. Yes, humus is made up of dead decaying waste and dead organisms. What we know that humus plays a very important part in terms of soil fertility. It improves the fertility of that particular soil, so that when you talk of plants growing, then they can use these decaying waste and dead organisms as nutrients, and these plants will be able to grow well. So we are saying humus is important. And another component of soil is water. Water is within also soil, and then we also have the fifth component of soil as a resource. We have dissolved minerals. We have dissolved minerals and gas these are found within the soil. So we can see that soil is made up of these close 5 things. So appropriate soil that can be able to support living organism, that can be able to support plants to grow well, then it needs to have fine particles, that's fine rocky particles, those are the sediments. It needs to have living organisms. They do those activities. When they move up, they improve the aeration of soil. Then we need to have humus, dead decaying, waste decaying matter, and live dead organisms, so that the soil can improve its fertility. Then we have water. Water, when is within the soil, then the plants can grow well using the water that is available within the soil. And we know there are different types of soil, and their water holding capacity is different. For instance, when we talk about sandy soil, percolation water can pass through it very fast. So if there are crops growing on sandy soils, if it rains, the sandy soils can lose water very fast. Then you'll find if the plants are growing there, they will require constant rain or constant supply of water for the plants to grow, because the sandy soil are losing water faster. When we talk about loamy soils, they can be able to withstand, they can be able to hold water for at least a longer period compared to sandy. Clay soils, they have a high capacity of holding water, but when it comes to aeration, they have poor aeration when we're talking about clay soil. So we have seen the components of soil. Now we want to see soil non-renewable resource. We want to see soil as a non-renewable resource. We have soil, yes, we can be happy that it is soil, but we are saying soil is a non-renewable. It is a non-renewable resource. Therefore, we need to use it with the precautions so that we don't endanger the living organisms, and we don't endanger the lives that soil is supposed to support. Soil, a non-renewable resource. When we talk of soil being a non-renewable resource, we can have an argument and say, no, soil can be a renewable resource. For instance, if I have, maybe you have a particular garden, you have a farm, and you can use farmyard manure, you can take other soil you add, and maybe if there are deposits, if water collects some particles from an area and it brings this soil to a particular river, you can say soil, it is brings other good soils from elsewhere and is bringing it to your soil, and then you can say, yes, it is renewing my land. But the question we need to ask, where these particles are being taken from? How can those particular places regain its fertility, regain the soil? So we are saying, no, things do change. So when we say soil as a non-renewable resource, we are saying in some places, the rocky particles are carried by water, it is true, wind, it is true, ice, and they can build up quickly. The soil can build up quickly. But we are saying, we have examples where rivers will carry soil through erosion. If it is through erosion, then the areas that are being eroded, to replenish themselves back, it becomes difficult. Soil will be moved from one end to another. Where it is being moved, you will talk of it is gaining, but where it has left, how can the area that has has been eroded, how can it regain its first structure? It becomes difficult. Or if there is a storm or a tornado, it can be able to take dust and blow up all this soil in the air and so forth. Then it brings a problem to that particular area where it has interfered with. So we can say soil can also be carried from curtains to farms, adding fertilizer. You can add fertilizer, the man-made fertilizer, like mulch, the rotting leaves, and so forth, and twigs, to improve the nutrients of that particular garden and so forth. We are saying it's okay. However, most places on earth, soils are not being renewed. So we compare. We should not just say you are adding fertilizer. We want to compare the earth generally, what is happening. So we are saying they're not being renewed. If farmer soil blows up away by wind, then by maybe a tornado, it becomes very hard for you to replace it. So if it takes very long time for you to replenish the soil that was lost, then we say because it takes many years more than the lifetime of a human being, then we say soil is a non-renewable resource. So we are saying, however, this process takes hundreds of and thousands of years to form. Soils only in a few, it will only form a very few centimeters thick. So we can say that if it takes many millions to form just few centimeters thick of soil, and yet it had eroded a large sums of chunks of land and so forth, then we say soil is an unrenewable resource. And because it is a non-renewable resource, then we have to think of processes, conservation processes that we can use to conserve soil, because we know how soil is important. It's a very important source. Therefore, it's a very important resource. Therefore, we need to protect it because it's very important. So we can see conserving resources. There are ways we can be able to use to conserve resources that are scarce. So conserving resources. We want to see how we can conserve resources that are limited. And we shall be able to discuss these resources by naming them, or conserving resources. Therefore, when we talk of conserving resources, there are several ways we can save our valuable resources. If we have resources and these resources are supporting us, then it is our own responsibility to ensure that these resources that are supporting us we are able to use them to maximally and to limit their use. We don't have to be wasteful. So we are saying, for us to be able to conserve these resources, then the first step is limiting consumption. Now, when we talk of limiting consumption, what do we exactly mean here? We are saying everybody, it is a responsibility of everyone to avoid wastage, to avoid wasting resources by only using the much resources as it is needed. It is serious for you to overuse resources, to use resources that even you don't require. So we are saying use resources only to the extent that you are required, where you are satisfied. So we are saying, for example, if you can be able to save energy by turning off lights that are not needed in other rooms. Why should you turn lights on in some of the rooms you are not? You can only turn rooms where you are using them. So it is uneconomically important for you to turn lights in places where you are not using. So we are saying, for you to limit resources, turn lights where you are. Some rooms that are not being used, then turn lights off. So when you do such a process, we are saying it is an example of limiting consumption. You are limiting consumption by only using the lights that are important, that you are using, because you are in that rooms, you want to use them. The rooms that you are not using, you put off the light. You are doing what we call limiting the consumption. You don't just exploit consumption and you misuse energy in any way. Then we are saying there is also a second way that you can be able to use to conserve resources, And this second way, we call it increasing the price, increasing the price. Now, when we talk of increasing the price, this is a situation whereby human character is funny. If they knew that a particular resource is a bit expensive, then they will be careful with that particular resource. They will not want to waste their hard-earned cash anyhowly. So when the government decides now to increase the price, they are trying to tell these people to be cautious, because if they know it is cheap, they will not mind the way they are using it. But if the government increases the price of that particular resource, then people will be cautious because they don't want to lose their hard-earned cash. So we are saying when you increase the price, it is a strategy used by the government to encourage people to limit resource use. It is to charge a lot for resources such as water. They can charge a lot for resources such as water, so that people cannot just leave water running, leave their taps running and wasting water anyhow. So you'll find that if they charge high on water, people will take care. They will take care of water. They will use it only when it's important. And also they can charge highly when it comes to gas and electricity. They can charge high electricity. Then people will be careful on the way they're using electricity. This works out because people will not waste a resource if it costs them a lot of money. People are careful when something is costful. They are careful. They don't want to waste it. So by increasing the price, people will be very careful with that particular resource. If it's water, if it's gas, if it's electricity, they will now learn how to use it properly than wasting it. Okay, there is also another way of ensuring you conserve resources, and the third way is using alternative resources. Using alternative resources. When we talk of using alternative resource, we can have a strategy where you limit the use of a particular resource to develop the alternatives to it. So if you know that this particular resource is scarce, and there is an alternative which is present in plenty, then you can limit the resource of these scarce resources and use the alternative. In a way, you will be conserving this scarce resource. For example, we have cars which use petrol fuel. We have cars which use petrol fuel, and as much as the information we have is petrol fuel is a non-renewable resource. We can use it to the extent whereby it will have depleted. There is no way we are going to extract more petrol fuel, the fuel that we have. So we can have an alternative for cars. Instead of using this petrol fuel, they can come up by making electric cars. So electric cars becomes an alternative to a petrol car. Instead of using a petrol car, using petrol for moving and driving around, you can use the alternative, which is electricity. Then you find that you are now conserving the scarce resources, which was petrol fuel. So we are saying that's okay. You will save petrol, which keeps oil. Oil is an important resource. So we are saying then the oil can be used maybe to make other products like plastics and so forth, which are also important. So we are saying using alternative. If we know that even a car can use gas, then we can use gas slightly, then we use petrol slightly, or we use electricity. If electricity can be able to drive that electric car, then that's a clean energy, which is okay, so it's an alternative use. Then another process where we can ensure that we are doing what we are conserving our resources is making public awareness. So public awareness campaigns. Public awareness campaigns. Public awareness campaigns. Public awareness campaigns. People need to be told how to conserve vital resources. People need not to be ignorant. We are saying when people are ignorant, they may not know how they are supposed to use these vital resources. So we are saying, another way we are saying, if people are given correct information on how to use these vital resources, the better. They will use the vital resources appropriately. So we are saying when we talk of public awareness campaigns use the media. The media is used to educate people about the need to conserve resources. These campaigns encourage people to limit their consumption because it saves them money and is better for the community. So once people will know that, please, when you have information on how you are supposed to use the vital resources, you will use them correctly and you will be able also to save money than misusing the hard-earned cash. So when people are given correct information, we say information is power. They are given information on how they are supposed to use the resources that are vital to them. When they get this information, they will be able to use the information very well, and if they use the information very well, it will be for the betterment of themselves as individuals and betterment for the whole community and the society at large. Another way we can use to conserve the resources, we talk of recycling. The fifth way we can use, if we feel this thing can still be used, why throw it away? Bring it back so that it continues to benefit the society. So when you talk of recycling, we are saying recycling is the process of reusing the particular materials. So we are saying recycling is the process of reusing the material rather than throwing them away. If you throw them away, you are losing. If that, whatever you want to throw away, can still be reused, then you use it. So if you use it again, we are saying you are recycling that particular materials. So we are saying in a way, for instance, when we give an example of maybe aluminium, if you have extracted aluminium and you want to draw that particular aluminium, instead of you going back to mine the aluminium ore so that to make aluminium, you can recycle the same aluminium and you will have conserved the aluminium ore. Instead of going again to mine it to extract the aluminium ore, you can just recycle the aluminium that you have. So we are saying recycling materials such as iron, copper, and paper, wood, clay, bricks, and so forth, they save resources because if you don't recycle them, it will mean you will now go back and mine, and that will mean that more extraction, more mining, and that particular resources will get depleted. So we are saying in a way, if you have things that can be still reused, please reuse them. If you have a paper bag and it can still, if you use a paper bag to carry some things, and you have completed carrying whatever you are carrying, and still that paper bag can be still to carry other things, then please you can preserve that paper bag, you go and carry other items than just buying a new one and so forth. So recycling is important as long as it limits it limits the use of the scarce resources so that it does not get depleted faster. Also, we have factors that guide the choice. We have factors that will guide how can we use this particular resource. So choice and resource development. What do we consider for us to say, yes, we are going to mine, we are going to extract these particular resources, we are going to use these particular resources. There are a number of factors that will be able to dictate whether you are going to have options, whether you are going to use that particular resource or you are going to use the alternative. So we can have choice and resource development. So we are saying once we have resources that are present within us, there are some things that we need to ask ourselves before we decide to extract a particular resource. One, we ask ourselves, by extracting that particular resource, is it viable? We have to look the method of extracting that particular resource. Is it expensive? Is it cheap? What about the implication to the atmosphere? How is it going to affect the surrounding environment? Is it going to be danger to the society? Is it going to affect negatively the environment that is there or the ecosystem? So there are a number of things that will guide people when it comes to choosing resource development. So we can have this heading, subheading, choice and resource development. Now, when we are talking about choice and resource development, we need to put these two factors into consideration. We are saying the major factors that affect a resource development are, it is environmental impact. What is the environmental impact of a particular resource? If you have decided to extract it, how is it going to impact the environment? So one, its environmental impact, and the economic benefit, the amount of money it brings to the local community and to the country as a whole. So we have to consider, one, the environmental impact. How is it going to affect the ecosystem? How is it going to affect the animals that habits that particular environment? Is it going to affect them negatively or positively? So we look at the environmental impact. That's the first factor that has to be looked into. Two, what profit, economic factor, what profit does it bring to individuals or to the government at large? So we are saying two factors are very important. How does it affect the environment? How does it affect the ecosystem? How does it affect the organisms that are living within within it? Then to the money, economic factor. Is it cheap? How are we going to gain a lot of money from it? So those two factors are very important. We are saying the economic benefit gained from mining from mining a particular resource is affected by the changing prices obtained for that particular resource. If we are mining a particular resource, yes, we are mining a particular mineral and so forth. What are the prices of that particular resource? If the prices are high, then we know that if we mine it, we are going to make more money. So there will be higher probability that we are going to mine that particular resource because in the market, the prices are high. But if it keeps on fluctuating to the extent whereby if we mine a particular resource, when we go to sell it to the particular market price, it is as if it is a loss. Then it will be uneconomically viable to extract such a kind of minerals while there's no profit. So we're saying factor number one, what is the price? Is it expensive? When we extract it, we can be able to sell and gain profit. If we are not gaining profit, it's a loss, then it becomes uneconomically viable to mine such a kind of minerals. Then we are also saying, as long as whatever we are mining is profitable, then maybe we can continue to mine that particular mineral because it is bringing profit. We shall only stop when that particular mineral runs out. If you are mining iron, when the iron runs out, whether it was profitable or not, you will not continue mining iron while it has depleted. It is finished. You will only stop. It was good while the prices were high, but once it runs out, you will not continue. So you will stop your activity of mining. You are stopping because the mineral you are mining is no longer there. So we are saying that factor, you will mine because of the price is good, yes. You can stop mining because the particular mineral you are mining, it's no longer there. And two, if it has adverse effect to the environment, then for the benefit or for the public good, then we can leave to mine that particular mineral because it has adverse effect to the populations that are living within. So we have to consider the effect on the environment. Also another process, we talk of new technology. Technology will keep on coming. What will guide particular individuals in choosing particular technology to mine particular minerals. Maybe if you are using traditional methods to extract some minerals, you might not, those methods can become obsolete whenever technology comes in. So we are saying new technology can be allowed, and we can entirely allow a new technology when it comes to mining. For example, if that particular technology, the new technology, is cheaper, the way it's being used, it brings costs down, and you are able to extract what we are having. And if that also new technology is not causing a lot of adverse effect to the population and to the environment, then we'll say, yes, this new technology of extracting minerals, we can use it. We are saying we can give an example of fracking. Fracking is a new way of mining minerals from rocks. We are told mining is a process whereby water and other chemicals are pumped into rocks. When they are pumped into rocks, they cause these rocks to fracture or to break. And when they break, they allow the resources to escape from the rocks so that they can be extracted. We have a process, a new technology called fracking. And we are saying fracking is a process whereby water and other chemicals water and other chemicals are pumped. Water and other chemicals are pumped into rocks. They are pumped into rocks. When they are pumped into rocks, they cause these rocks to fracture. Causing them to fracture. They break, and once they break, then they are able to extract that particular minerals they want. So such a kind of process of fracking, they've used fracking to get gas called they call sim gas. They are able to get it through this way. There have been cases, for instance, in other countries like America, where people will come up and demonstrate. If they feel that fracking is a process, yet you are gaining minerals, you are getting whatever you wanted, but if those minerals, you are contaminating the environment, maybe you are contaminating the water resources, and these water resources are being used by most of the people living around, then people can come up and demonstrate against such a process. They say, yes, this is a new technology, you are using it to gain these minerals, but it has adverse effect because our water that we are using for human consumption are being contaminated. So we are saying in a nutshell that cost and the efficiency are major considerations when it comes to a new technology. If you want to adapt a new technology to extract particular minerals, then you have to consider cost. Is it very expensive for you to use that particular new technology? If it is very expensive, then it will be uneconomically viable for you to choose that option. And then also, if it's a new technology, how efficient is that particular new technology when it comes to extracting that particular mineral you want? If it is very effective and efficient, then you will be able. So when we talk of when do you say that particular technology you are going to choose it? You will choose a particular technology depending on the efficiency of that particular technology to extract the minerals that you want. So we shall talk of the cost. The cost, how is it? If it is costly for you to use that particular technology, then you will not use it because it's costly. It becomes uneconomically viable for you to use a new technology that is not cost effective. Then we are saying the efficiency. If that particular new technology can assist you effectively to extract what you wanted, and then you say, it's okay, then I will use this kind of technology. So we have been talking of fracking. Fracking is okay, where we talked of that rocks are broken into water, fracking, where we talked that water is pumped into and some chemicals are pumped into rocks, then you get the minerals. It's a new way, it's okay. But if it contaminates the environment around, people will come up, the environmentalists, and they will be able to come up with a demonstration that, okay, this new technology, the environmental impact is dangerous to the populations that are living within. So in a nutshell, we are saying it becomes difficult decisions for you to decide what kind of technology you are going to use. So the environment will become very important because that particular technology, what is the impact to the environment? If it damages the environment, then that technology is not good. But if there is no damage to the environment and the technology is cheap, cost effective, then you can be able to use that particular technology. Now, when we talk of burning coal, coal has been used as a source of energy in most countries. The danger that is there with coal burning is it emits. It will generally emit when you burn. When you burn coal, there is a process called there is a gas called carbon dioxide gas that is emitted, and when it's emitted and sent into the atmosphere, it causes what we call warming up of the Earth's atmosphere. When the Earth's atmosphere gets warm, or it gets warm, it will affect some places. The climate can even change. You will find that in some countries the deserts will come and yet the deserts were not there. So we are saying when you continue burning coal, it has adverse effect to the environment. It will affect what we call ozone layer. And we know, as we had mentioned earlier, that ozone layer is very important as far as human life is concerned. For instance, ozone layer, it protects us against the ultraviolet rays, that when these ultraviolet rays, they get into contact with the skin, our skin, it can cause skin cancer. So if we decide we continue burning coal anyhow, then this coal is going to affect the atmosphere. Then that ozone layer that was protecting us, it will get depleted, and the sun's rays that are dangerous, the ultraviolet rays that comes from the sun, they will be able to penetrate through the Earth's atmosphere and reach us, causing a lot of disease and so forth. So we are saying when it reaches to that level, then we say it is dangerous. Why should we continue using maybe burning oil? We can also use other clean energy resources that are there. We can either use electricity, which is okay. We can use solar energy, or we can use even wind power. It is a clean, renewable energy than using a dirty energy that is interfering with atmosphere. Then when we are talking about choice and conservation, how to conserve and to use appropriate resource, we can relook how the indigenous people were trying to conserve the environment. How were they using these resources? So we are saying indigenous people and the resources, the knowledge that we can gain, this little knowledge, however little it is, we can gain from the indigenous people. Then we can build it from there, from the knowledge they have, then we can build from there. Of course, it is important for you when you are conserving the environment, you are using the resources, to involve the indigenous people, because if we don't involve them, they will not know how to take care, to conserve the resources and so forth. So it's better you involve people. When you involve them, they will learn, they will know how to conserve these resources. Therefore, in a nutshell, what can a government, what can a country do to ensure that they involve the indigenous people in the process of conserving the natural resources, the resources that we have? We can proceed maybe to say for us to protect the environment, we can do the following. We can do the following for appropriate conservation of the environment, and we are bringing in the indigenous people. Then the population will need to do the following. The government can do the following. Point number one, all local governments have will encourage people when they are developing these resources, whether they are national parks where people can rest. So encourage people, let people be involved. Let people be involved in managing resources. When the government involves people in managing resources, the people will own up that process as their own. Therefore, it will be upon them to ensure that the resources are managed well. Then we also have green teams. We have green teams made up of indigenous people, sites. They will advise on resource development. We can come up with people who are well informed, with experts. So we can have teams. We call them green teams, people with expert opinion on the management of resources. These are people well informed when it comes to management of resources. They will be able to give correct advice when it comes to management of resources. Another way the country or the government can be able to manage resources, they can come up with laws, state laws. They can define how places are supposed to be used, how the resources should be used. So laws can be enacted, state laws. They can be made to protect indigenous forest and so forth. State laws can be made, laws can be brought up, and when these laws are brought up, they can be enacted. When laws are enacted, they can be able to help people to conserve this environment. Another way, we can have native people. Native people can be given title deeds to enable indigenous people to have a claim to traditional lands. Therefore, the state can also give the natives title deeds to preserve native lands. If we give them that title deed, then these native lands can be preserved. But from the much we have covered, we can have a number of questions to aid us in revising what we have covered. For instance, question number 1, state 2 major factors that affect resource development. State 2 major factors that affect resource development. We have said for you to manage a particular resource, for you to extract a particular resource that you're using, you will be guided by 2 important factors. 1, how is that resource that you want to extract? What is the environmental impact and what is the cost? What is the benefit in terms of monetary to the individuals and to the community? Then question number 2, describe the process of fracking. Describe the process of fracking. We had said the process of fracking is whereby water and chemicals are pumped into rocks. When they are pumped into rocks, they cause these rocks to fracture or to break. And when they break, they are able to extract the minerals they want from these rocks. That process is called fracking, where water and chemicals are pumped into rocks to make these rocks to break down or to fracture so that they release the chemicals they want. So other questions, we shall be able to cover them in our next topic, and our next topic will be on energy resources. Energy resources. We have energy. How do we conserve this energy? Thank you.